All right, number 14, you have accompanying figure that shows regions bounded by the graph of y equals x times sine of x. It is separated into R1, R2, R3, R4, and those areas are 1, pi minus 1, pi plus 1, and 2 pi minus 1 respectively. We're going to use this information to evaluate the following. So we are wanting to evaluate integral from 0 to pi of x times sine of x dx. All right, so from 0 to pi, if we look at this figure, this would be 0, and then here is pi. So we're only looking for regions 1 and 2, and we have 1 as the first region R. So we got R1 plus R2, and that is 1 plus R2 is pi minus 1. So the plus 1 minus 1 cancel, and that just gives us pi. So the area of this function is just pi. All right, number 15 says the figure to the right shows the area of regions bounded by the graph of f and the x-axis for the following integral. This is from b to 0. We want to evaluate the following integral, sorry. We want to evaluate b to 0. So here's b, and then going back to 0. So this is positive, this is negative. Usually you would flip it when the integrals are backwards, because it would work out that way. But we have integral from b to 0 of fx dx that's equal to negative of the integral from 0 to b fx dx. All right, so this integral from 0 to b is going to be 21, and then we would subtract 3. So 21 minus 3 will give us 18, so we'll get a negative 18, following that property of integrals.